Hey guys, we are going to get started on lesson 3.3. It's a 2-day lesson, so this is day 1. Let me present my screen and we'll get started. Okay, so in this lesson, we're going to learn another way of solving quadratics, which is by completing the square. All right, so completing the square, it says here to add a constant c to an expression of the form x squared plus bx so that x squared plus bx plus c is a perfect square trinomial. All right, so here's an example of how to complete the square. This here is a perfect square trinomial and it factors into x plus 3 squared. You can still do guess and check as we often do to factor this, and you would get x plus 3 times x plus 3. And since the binomial repeats itself, we write it as x plus 3 squared. Okay. This whole b divided by 2 squared thing, I'll explain that as we go through the process. And you might remember this from Algebra 1 because you did learn how to complete the square in Algebra 1. All right, so in words, it says to complete the square for the expression x squared plus bx, it says you're going to add b divided by 2 squared. All right, in the diagram, this is a visual illustration of what we're actually doing when we say completing the square. And then it shows the algebra behind it. When you add the b divided by 2 squared, it becomes a perfect square trinomial that factors into x plus b divided by 2 and x plus b divided by 2 again. And since they repeat, we write it as a binomial squared. Okay, so the first 3 we're actually going to solve by using square roots. So we're not quite getting into the completing the square process yet. We're getting ready for it. There are steps to follow. So I'm going to write the steps down and then we'll get started on the problems. All right, so hopefully my pen behaves today. All right, so the first step when doing these problems is to factor the perfect square trinomial. Then after you factor the perfect square trinomial, you're going to solve by square root. Okay, so let me just get this out of the way a little bit. Over here. For the first problem, we're going to see if this left-hand side factors. Again, if you don't recognize the perfect square trinomial pattern, then you can always just do guess and check. So if I was to do guess and check, I would say to myself, okay, what 2 numbers multiply to 4 and those same 2 numbers add to 4? It would be 2 and 2. So it's x plus 2, x plus 2, and the other side is equal to 2. Now, because those binomials match, we write it as x plus 2 squared equals 2. Now, if the goal is to get x by itself, to solve for x, you have to get rid of this square, right? Because the x and the 2 are stuck in the parentheses. So the inverse operation of squaring is taking the square root. So at this point, I'm going to take the square root of x plus 2 squared. And then I'm also going to take the plus minus square root of 2. I have to take the square root of both sides because whatever I do to one side, I have to do to the other. So the square root cancels with the square, and you're left with x plus 2 is equal to plus minus the square root of 2. Now, the square root of 2 doesn't simplify. It's not a perfect square factor underneath, so we just leave it like that. Now we just need to get x alone by subtracting. Okay, so we have x is equal to negative 2 plus or minus the square root of 2, and that will be your final answer. There are 2 answers there. It's saying that x is equal to negative 2 plus root 2, and x is equal to negative 2 minus root 2. Okay. All right, let me clear and go on. Okay, so for the next problem, again, you're going to try to factor the left-hand side. If you recognize your perfect square trinomial patterns, you know that a negative 20 times a negative 20 will multiply to give you a positive 400, and a negative 20 plus a negative 20 will add to give you a negative 40. So I can quickly factor it into t minus 20 squared equals 300. Now we're back in the same scenario as we were for the last problem, where I have to take the square root of both sides of the equation in order to get rid of that square that has the t trapped in the parentheses. So I'm going to write it like this. Take the square root of both sides. Don't forget your plus minus. The square root cancels with the square. So you're left with t minus 20 equals plus minus the square root of 300. Now at this point, you could simplify the square root of 300, or you can move the 20 over. It doesn't really matter. I'll simplify the square root of 300 first. So I have t minus 20 is equal to plus minus, well, 300, and I'm going to write this one out just to review square roots. That can be rewritten as 100 times 3, both under radicals. And since the square root of 100 is 10, now I have plus minus 10 root 3. Okay, so the root 300 simplifies to 10 root 3. Now I'm going to add 20 to both sides, so move that over by the inverse operation of addition. And I'm left with t is equal to positive 20 plus minus 10 root 3. Again, this quadratic has two solutions when solving by square root. We have 20 plus 10 root 3 and 20 minus 10 root 3. The next one, I'm going to try to factor. Hopefully it factors into a perfect square trinomial. All right, so what two numbers multiply to give you 9w squared? It's 9w. What numbers multiply to give you a positive 1? It's a plus 1. If you take 3 and the 1, multiply together and double it, so 3 times 1 is 3, double it is 6, you get that middle term. Again, if you're not comfortable jumping right to this point, you can guess and check first. All right, so now, just like the last few problems, I have to take the square root of both sides. So don't forget the plus minus the square root of negative 18. The square root and the square cancel, so you're left with 3w plus 1 is equal to plus minus the square root of negative 18. Again, it's up to you if you want to move the 1 over, then divide by 3, and then simplify. I'm going to simplify the square root first. So the left-hand side stays the same for now. There is a perfect factor of 9 and 18, right? 9 times 2. And it's a negative under the radical, so I know it's imaginary, so it's going to have an I. Remember, we learned this in the last lesson. So it's 3i root 2. 3i root 2. Now I'm going to subtract 1 from both sides. So I have minus 1, minus 1. This cancels, so I have 3w equals negative 1 plus minus 3i root 2. And finally, divide both sides by a 3. So you're left with w is equal to negative 1 plus minus 3i root 2 all over 3. And that's your answer. Okay. Let's move down to the next problem. It says, find the value of c that makes the expression a perfect square trinomial. Then write the expression as a perfect square trinomial. So for this is what in our notes at the very beginning, we were saying that c is going to equal b divided by 2 squared. Okay, so when we look at this first, oh, here we go, doing its own little thing. When we look at this first problem, my a value is a 1. It's the coefficient of the y squared. My b value is a negative 14. Okay, so c is going to equal b divided by 2 squared. So I'm going to have negative 14 divided by 2 squared. That's negative 7 squared. So that's 49. Okay, So let me give myself a little more room. So now I know that C is equal to 49. All right, so C is, sorry guys, I pushed the button I wasn't supposed to. Try that again. Okay. So I had that B was equal to negative 14, and now I know that C is equal to 49. All right, so then my perfect square trinomial is y squared minus 14y plus 49. All right, then it says, then write as an expression as a square binomial. So that again, I'll show the guess and check version, but then we'll start recognizing the pattern. What two numbers multiply to 49, but the same two numbers add to a negative 14? It's y minus 7, y minus 7. Because the two binomials match, I write it as y minus 7 squared. All right, and that will be the final answer there. Okay, let's do another one. So for this one, my A value is 1, my B value is 17. To figure out my C value, I take B divided by 2 and I square it. So that's going to be 17 over 2 squared. Now 17 is not divisible by 2, and I'm not going to use a decimal. So just square the 17, which is 289. And square the 2. You have to square both of them to get a 4, right? Because you're squaring the 17, squaring the 2, or you could also think of it as 17 over 2 times 17 over 2, right? When you square something, you're multiplying it times itself. So that's where the 289 over 4 comes from, okay? Oh, I erased some of it. I have to rewrite that part of it. That's a 4 under there. Okay, so now I know the C value. So my polynomial is s squared plus 17s plus 289 over 4. Now you might be thinking, how am I going to factor this? For this one, again, I'm going to show the guess and check just so you kind of understand. So I know it's going to be s and s. I have to think about what two numbers multiply to give you 289 over 4, and the same two numbers add to give you 17. Well, that's an odd question to ask, but think about what you just did in the step above. What two numbers multiplied to give you this? The two numbers were 17 over 2 times 17 over 2, right? So I'm going to have a 17 over 2 here and a 17 over 2 there. And if you take 17 over 2 plus 17 over 2, right, you're going to have, keep denominators the same, add the numerators, that's going to be 34, and 34 divided by 2 gives you 17, okay? So that's how I know how to factor it. All right, let me go back. And since the binomials are the same, oh goodness, since the binomials are the same, I write it in a more simplified way. Just give myself a little more room. I write it as S, oh, I forgot my sign. Sorry guys, it's plus and plus. S plus 17 over 2 squared. Okay, so again, they asked for the value of C. Here's my value of C, and then they asked you to write it as a perfect square trinomial, which is right there. So those will be the two answers for this problem. All right, oh, I'll just erase the whole thing. And this last one. So again, my A value is 1, my B value is 24, my C value I'm going to figure out by doing B divided by 2 squared. So I have 24 divided by 2 squared. That's going to give me 12 squared, which is going to give me a 144. So now I have Z squared plus 24Z plus 144. So what two numbers, and think about what you just did above, what two numbers multiply to give you 144, and those same two numbers add to 24? It's 12, right? So it factors Z plus 12 squared. Okay. All right, let me scroll down. Okay, oops, last three problems. Solve the equations by completing the square. So the last thing we just did kind of got us ready for this. And there are steps. Let me write down the steps first that you follow for completing the square problems. The first step is you're going to make sure A equals 1. And I'll show you what to do if A does not equal 1 as we get into problems where we see that. Then we want to write in the form ax squared plus bx plus blank equals c plus blank. Okay, then after we do that, we're going to complete the square. So that's the step we just did above. C equals negative b, C equals b divided by 2 squared. All right, then we are going to factor. And finally, we're going to solve by square root. So we start by using the complete the square method, but then we actually finish by solving by square root. Okay, so for the first problem, my A value is a 1. I can already see that. And if I want to list them, I'd say, okay, A is 1, B is negative 6, and I'll have to figure out C in a second. Then it says write in the form ax squared plus bx plus blank equals c plus blank. Well, I don't know where any of that just went. Didn't mean to erase it. So try this again. Okay. Now I'm going to get all my little alerts. Sorry, guys. Let me just take care of these real fast. Okay. So again, my A is equal to 1. My B is equal to negative 6. I'm going to move this current C to the other side and set it up for completing the square process. So I'm going to move it by addition. So add a 2 to both sides. This is fun. Let's try this again. A equals 1, B equals negative 6. Move the C to the other side by adding and set it up for completing the square. So r squared minus 6r plus blank is equal to 2 plus blank. I have blanks on both sides because whatever I do to one side, I have to do to the other. What goes in this blank is your new C value. C is equal to B divided by 2 squared. So I'm going to have negative 6 divided by 2 squared. That's negative 3 squared, which is 9. All right, so a 9 goes in the blank on both sides. Whatever you add to one side, you have to add to the other. Then the steps that used to be written here said to factor. So factoring the left-hand side, it's always going to be a perfect square trinomial. It's r minus 3 squared equals, and then add the 2 terms over here, 11. Now we solve by square root because we want to get r alone, but it's stuck inside the parentheses because of that square. So take the square root of both sides. Don't forget your plus minus. The square root cancels with the square, so you're left with r minus 3 equals plus minus, here we go again, square root of 11. 11. Right? Then you're going to, once my pen stops having a tantrum. Okay, then you're going to add 3 to both sides. Not even going to bother erasing, guys, because this is annoying. So you have r is equal to positive 3 plus or minus the square root of 11. And that would be your final answer. All right. All right, let's see if this next problem gives us as much trouble with the pen. Yep. Okay, nope. So my A value for problem 8 is 1. My B value is a 10. I'm going to move the current C to the other side. So I'm going to subtract. I'm going to subtract a 28 from both sides of the equation. Subtract 28. subtract 28. So my equation becomes x squared plus 10x plus blank equals negative 28 plus blank. I'm set up for completing the square. So I have to calculate my new c value, which is b divided by 2 squared. That's going to be 10 divided by 2 squared. That's 5 squared, which is 25. So that's what goes in the blank. Right. From there, now I need to factor the left-hand side. All right, so to factor the left-hand side, that factors into x plus 5 squared. And then you combine like terms on the other side of the equation, which is going to give you a negative 3. Now you're going to take the square root of both sides. So x plus 5 is equal to plus minus the square root of negative 3. It's imaginary, so don't forget that I, right? So plus minus I root 3. And then finally subtract 5 from both sides. And you have x equal to negative 5 plus or minus I root 3. Okay, and the last problem. Now this one looks much different than the others. You probably want to kind of clean it up first by distributing that y in so it kind of matches the other equations and has a y squared term. So I'm going to distribute the y into the parentheses and I have y squared plus y equals 3 over 4. Now, if that bothers you that it wasn't set equal to 0 like the last two problems, you could subtract the 3 over 4 from both sides. But if you think about it, once you move it over, y squared plus y minus 3 over 4 equals 0. Once you move it over, the next step is to move the c to the other side and get ready for completing the square. So it's really not necessary to do that step, right? The c is already over there. So all I need to do is write it again and leave room for completing the square. So y squared plus y plus blank is equal to 3/4 plus blank. Of course, plus blank. Less blank, okay? So to figure out what goes in the blank, this is where you do b divided by 2 squared. The b value is a 1. I didn't write them down this time, but 1 divided by 2 squared. Square the 1, square the 2, so you have 1/4. That's what goes in both blanks. Okay, so what two numbers multiply to give you 1/4 but add to give you a positive 1? It's going to be y plus 1/2. And then it's equal to, combining like terms on the other side, if you have 3/4 plus 1/4, that's 4/4, or just a 1. Now you have to solve by square root. Get rid of that square by taking the square root of both sides. So I have plus minus the square root of 1. The square root of 1 is just 1. So I have y plus 1/2 equals plus minus 1. Subtract the 1/2 from both sides. So y equals negative 1/2 plus or minus 1. Now this problem is a little different than the others because the others always had like some kind of radical. So we kind of left it after we simplified the radical. But here I can actually write my two solutions. I'm going to write them over here. I have negative 1/2 plus 1. And I also have y is equal to negative 1/2 minus 1. So I can simplify even further, right? Negative 1/2 plus 1 is a positive 1/2. And negative 1/2 minus 1 is a negative 1.5, which as an improper fraction is negative 3/2. All right, so y is equal to negative 3/2 and y is equal to 1/2. Okay. All right, I think that was all for today. Let me just make sure I scroll down. Yep, I don't see any more. So that is it for lesson 3.2 day 1. Meet me back here for the next lesson. Thanks. Bye.